I was curious if I could make my own e-bike. So what I have here is an old 20-year-old BMX bike that I got off of Facebook Marketplace, and I wanted to see if I could try to convert it into an e-bike. So my initial plan was quite ambitious. I was going to see if I could make a friction drive and model and 3D print those parts on my Bamboo Lab printers. It was kind of hard to get that friction drive to work. I think with enough playing around with it, I could have gotten it to work. And then I decided to pivot, and I wanted to see how well hub motors work for an e-bike. Now there's two types of hub motors you can get. You can get a rear wheel or a front wheel. In this case, I got the front wheel because it is way less complex. A rear wheel, you have to deal with the gears, if there are gears. In this case, there's just one gear, but there's still a level of complexity that you'd still have to get all those mechanisms to work together in tandem. Whereas on a front wheel drive, like in this case, you don't need to worry about that. It's much more simple. So in this video, I'll show you how I made this e-bike using one of those cheap conversion kits that you can get on AliExpress or Amazon. I got mine off of Amazon, but I see them on AliExpress, and there's loads of them. In this case, I bought everything all together, so one package, so it's very simple. All I need to do is provide a battery, which in this case, it's powered by these DeWalt batteries, which I'll talk about more in the video. And just so you know, this is a lot of fun. I got this wired up just to test it. I got all the connections put in place. The diagram that came with it is absolutely garbage. I managed to figure it all out just through some trial and error. Obviously, the power is going to be the two largest leads, and I got it wired up to a FlexVolt 60-volt DeWalt battery. I got the brake levers attached, and then I got the key or the ignition or whatever you want to call it. It even provides the voltage. I guess I could peel that off. This is the throttle. Okay, let's try the hub motor now. This is the speed controller. It's all wired together. Switches that might not be 100%. I got to check those, and there we go. Something's rubbing. I'll fix that after. But it works well. It's quiet too. I like that. The other thing that's cool is if I have this going and I pull one of the brake levers, it kills the power to it, which is a nice feature. To mount the speed controller and battery, I modeled some parts in Onshape and 3D printed them on my Bamboo Lab P1S. I used 4mm hot melt inserts as the fasteners. These work really well and make screwing things together a breeze. Because this is a small 20-inch BMX bike, I didn't have many choices on the frame to mount the ESC and battery, because space was at a premium. To mount the battery, I 3D printed a battery adapter, but I also found some of these adapters on AliExpress. Be sure to get the correct ones that taps the battery for 60 volts and not 20 volts. Since the wiring was so long, I shortened them and soldered them together to ensure they didn't come loose. note on how the DeWalt FlexVolt batteries work. They can supply 20 or 60 volts. To access the 60 volt supply, these two pins need to be shorted, and these two push bars need to be physically engaged. These batteries are powerful and reliable because they can supply 60 volts and simplifies the need for a BMS and charging solution. Also, I made sure that this hub motor and ESC can handle 60 volts. This here is the speed selector switch for low, medium, and high speeds. I swapped over the brake levers with the integrated throttle kill switch. This is a 30 amp inline fuse in case of a short or too much current is pulled. I wrapped all the wires tightly with some harness wire wrap. This stuff works really good, and it's a wrap and not a tape, so it's really easy to take apart if I need to. To hide the wiring, I 3D printed some side panels and bolted them to the frame. And so that I don't get a bunch of questions when driving around with a big yellow DeWalt battery mounted on the bike, I 3D printed a cover to hide the battery. I also added some generic fenders. And there it is, a DIY e-bike done on the cheap, mostly. Total cost was $50 for the frame from Facebook Marketplace, $300 for the conversion kit, and $200 for the DeWalt battery, and then some, miscellaneous costs. I don't plan on biking out in the rain, but I will waterproof all the connections, as it's probably a good idea. Here is some footage of me driving around on it. The top speed is crazy fast for a bike this small, and it starts feeling a bit unstable, as this bike was meant for doing tricks and not really going fast. The only real disadvantage to this system is its front wheel drive, so sometimes the wheel can slip and it's not really suitable for going off trail. Stick to the pavement or pack down gravel trails. This here is going up a steep incline and you can hear the front wheel slipping. Using my Garmin GPS watch on tracking, I was able to see my top speed and other metrics to get a sense of how long a battery would last. I estimate the range to be about 10 to 12 kilometers on one charge. And this is with minimal pedaling. The nice part is the range is only limited by how many batteries I want to carry, and since they are off-the-shelf batteries, it simplifies the need to build a custom battery pack. There is a built-in low voltage cutoff too, so you don't over-drain the battery, which is not great for the health of the battery. Nice thing is because I can see the voltage on the handlebar LCD display, I can keep an eye on it and estimate how much range I have left too. Since this system works so well, I'm going to look around for a used folding bike and move the parts over to that, since this BMX bike is very heavy and only has one speed. This was more just a proof of concept. Well, I hope you enjoyed this video.